tomorrow. Okay, so draw two triangles. Two triangles can be formed by the given measures. Solve both triangles. Okay, 19. So we got A.
Byron, I like the haircut.
Okay, A, B, C. A is 64 degrees. Side C is 16. Side B is 17. Ooh, this is the short side, long side angle. How many solutions are we talking about? Two. Okay, now, the only thing that would cause a problem here would be what? If the height of the triangle is what? If the height of the triangle is greater than that opposite side, right? So, sine of angle, or sine of 64 degrees equals h over 17. What do you get? What is h? That'd be 17 sine 64. And what is that? Using our handy-dandy calculator, 17 sine 64. Whoa, can't type. 17 sine 64. 15.3. Is that good news or bad news? That's good news, right? That means that we definitely have an existing triangle. So we have the two solution situation is in effect. Because I don't know whether that 16 goes like that or it goes like this. Because there's two different triangles. So we could have the big one, or we could have the red one. The big blue or the little red. Solve both triangles. Okay. Sounds like a lot of work. Because we did this one. Let's see here. Let's go with the blue one first. So sine 64 over its opposite side, which is 16, equals the sine of angle B over its opposite side, 17. If only we knew how to cross multiply. 17 sine 64 divided by 16. And then invert the sign because we don't know what the angle is. I got a B value of 72.7. Any questions on how we cross multiplied that? And we're just multiplying these two and dividing by that one. And of course we had to invert the sign to find angle B. You guys all got that? Okay. So we could continue going down that path. So in the blue triangle, we'd have a 72.7 down there. And then we could find angle C. Angle C would be what? 180 minus 72.7 minus 64. $43.3, okay. And then we can find side C, right? Sine 64 over its opposite side equals sine of 43.3 over its opposite side, which would be side C. And a little bit more of that cross multiplication stuff gives me 12.2. Now that's the blue triangle. You have to do it over again for the red. But angle B is pretty easy to come up with because how do we find angle B if it's over here? Come on, you can handle this. What? You take 180 and you subtract the 72.7, right? Because we talked about how it's supplementary to that. 107.3. I know. Okay, so angle C would be found by taking 180 minus 107.3 minus 64. So it's got to be pretty small. 180 minus 107.3 minus 64. 8.7 degrees. It's a frigid angle. And then back to the law of sines. Law of sine 16. Okay, sine 64 over 16. And sine of 8.7 degrees over side C. Yes, what's the question?
So if the ancient 50.3, why is it
Okay, if the height of the triangle is 15.3, then what?
then why isn't it 3 or like the sine of 64 over 15.3?
Oh, remember the height in the red triangle, the height is outside the triangle. Okay? And so, sorry, let me finish this and then I'll answer your question. 2.7? Okay, go ahead.
When you draw the triangles, does it matter that the obtuse triangle is smaller than the obtuse?
It definitely will be.
How do you know that it's smaller?
If you mean in area, then, because if I draw, let's see if I can pick a different color, custom pen. Come on, I want to go with green. Let's get to green here. Let's go green. Okay, so okay. So if we went this way with the 16, come on, don't, or if we went this way with the 16, we don't know which way we should go. And the side angle is the situation that causes me to have to question which way I'm going, and that creates that green part that can be cut off from the blue one to give me the red one. So I draw the original one purposefully, the blue one, and then I can draw that other possibility back to make the obtuse looking red one. Yes, Miss Johnson.
Does it matter where you put the A, B, and C?
If you see this thing occurring right here, typically what I try to do when I draw the triangle is I try to exaggerate, and I want to make it so that I get this type of thing showing up because it's easier for our minds to think about it. So that's why I did what I did when I looked at the side angle. I want to know this side, and this angle. It just helps our minds to visualize it. If we switch it up and I'm drawing a different looking picture, you might get a little bit confused. So, quite honestly, Miss Johnson, I like to draw all my triangles kind of like that, even if it's not drawn to scale. And, because I know if that situation's coming up, that I'm prepared for it. Yes. I'm pretty sure this probably answers a lot of the questions you guys put in there. Yes, go ahead.
When you're solving the right triangle, how do you find H?
Well, we did that at the very beginning. The height of the triangle is not going to change. That doesn't matter whether it's the red triangle or the blue one. You imagine that you have a little right triangle going on right there, which is what I looked at the very beginning. And so if you think about a right triangle, that's a bad looking right triangle, but you had a 17 here, you had your height here, and you had an angle of 64 degrees. And so you just use your definition of sine, SOHCAHTOA, and that's how we count. That's how we came up with 15.3. Glad you remember your reciprocal trig functions. Yes. Any other questions on this one? I'll copy and paste that, put it back in the document. A lot of work. College will be interesting.
Always going to make this seem like a picnic.
Yeah, a walk in the park.
Do you think
What? Side C of the red triangle was 2.7. Side C of the blue triangle was 12.2. See how we did that on the left side toward the bottom? Oh, is this question? Yeah, be quiet. Quiet. Quiet on the set. Okay, so it's question 27. Let's go A, B, C.
So basically, my question is, I thought like
61, we got an A value of 8 and a B value of 21. All right. Let's see if we can find the height of this. Wouldn't it be weird if you like watched YouTube videos of a math teacher with it was like swearing and, you know, calling the triangle all kinds of bad names, you know? It would make it interesting. Okay, I don't think I could get myself to do it, but it would be funny. You'd be like, "What the heck's going on here?"
if you do that, you'd sound like Buddy Rich.
Buddy Rich. Is that Richie Rich's dad?
No, Buddy Rich, one of the best drummers ever. Who
Oh,
was also
yeah.
famous for the Bus tapes. Oh.
Okay, so 21 sine
look it up
61.
later.
21 sine 61 is what? What's 21 sine 61?
Wait a minute.
Trying to find the height here, folks. 21 sine 61. I feel like I'm so alone. 18.4. Is that a problem? That side 8 is never going to make it if the height is 18.4. So there ain't no triangle there. It's like this. See, it can't make it. Do you see the picture I drew with the red there? It's just like, it's like a little stick and it can't make it back to the other side. Okay, it's lost. Sorry. No triangle. Yeah, you need to find the height in order to determine whether there's any chance for... And then, of course, if you do find the height and it's good, okay, so let's say the height was less than the 8, then you need to look for the side-side angle situation where it has 2. And if it's that side, the short side, long side angle, then there's two triangles. Every other possibility is a 1. So if it's got a triangle that exists and it's not the 2 triangle situation, then it's in the 1 category. Yeah, I don't know. So let's see here. Sine 47 equals the height over 21. 21 sine 47? 21. Yeah, that doesn't exist either. Now.
He wants to go to college, Mr. Query.
My answer book has a different answer in there, and I don't Oh, they tricked me. They tricked me. They tricked me. Angle B is 47. Side B is 21. Side A is 8. So if I'm trying to find the height of this, okay, that would be sine 47 is h over what? It's not 21, folks. You need to be focused on this little triangle here. What's the hypotenuse of the little triangle? 8. Okay, so 8 sine 47 is the height. Because there's no way for me to find, I can't use the 21 in that other triangle because I don't know what angle A is. They didn't give that information to me, which is, they tripped me up the first time, which is why I thought it didn't exist. And then I was like, oh man, what did I do wrong? So that gives me 5.85. You can do whatever you want. Okay, so it does exist. And if you look at it, that's the long side, short side angle situation, which means there's one solution to that. And you should be able to go through the law of sines, and you should be able to figure out angle A, then find angle C, and then find side C. Going through the same kind of process we did before in that last example. But we definitely got a one solution situation going on for question 28. Copy that, put it back in the document. Whoops, wrong one. Okay, that'll come up today, so I'm not worried about that one. Okay. Yeah, I think so. I don't, unless that's a law. Is that a law of sines question? Oh, okay. It's, you've got a basic triangle here, so we'll set it up. But I don't think it'll be too earth-shattering. Except I didn't copy the actual question, so that's kind of ridiculous. You know. Find the distance between the canyon rims. Well, first you get a tape measure. Probably not going to happen. So they called that one C. Called this one A. They called this one B. This was 56 feet. And you just wanted me to find out the distance between the two canyon rims. That sounds like the height. Is positioned so that BAC, okay, BAC is 72, and ABC is 53. So, how do we want to find that that value? The H. According to this, that would be what I'm looking for. The height of the right or this triangle is the distance between the canyons. Or the canyon rim. Sorry. Do you have any choices here? Could you use this triangle, or could you use that triangle? I'm going to say we probably have to answer part A first before we can answer part B. Because you can't use either one of those triangles unless you have what? One of those other sides. Do you know the angle at the top?
Well, let's see.
Do we know that angle?
Figure it out.
180 minus 53 minus 72. What do you got? 55 degrees? Okay, so that should be enough information to do the sine 55 over the opposite side of 56 equals sine 53 over its opposite side. We'll call it little b. Okay, that's what its wrap name would be. Little b. Okay? So solve that for B, and then you have exactly what you need for finding the height of the triangle. Because then you could say that H would be B times the sine of 72. So find that value, and then plug little b in there, and then you find the height. And then you'll know the distance between the canyon rims. Okay? So I'll leave that into your capable hands. Copy and paste. Jump back here. Let's get some chapter 5. What do you hate? Oh, okay. Okay, when last we left our superhero, we discussed the beginning part of the law of cosines, how it is a more generic form. The Pythagorean form identity is a specific case when you have an angle of 90 degrees, which is why the term on the right disappears, because the cosine of 90 is 0. I did ask you to help me solve a very simple problem on Friday at the end there, something basic from Algebra 1. Now, the reason I had you help me solve that is I asked you one very important question. I said, would you ever consider taking that 9, right here, this 9, and subtracting the 2x and saying that that was equal to 7x? Would you ever think to do that? Okay. Now, you all tell me no, but then when we get into the law of cosines, some of you will completely ignore that. And I know you think you don't, but we'll get going here, and then all of a sudden, some of you are going to start, well, Mr. Staley, this says domain error on my calculator. Well, because you're not following the logic that you told me you would follow when we get to that particular question. Okay. So, got a triangle. When in doubt, draw it out. So side A is 11, side B is 5, angle C is 20. Is it a right triangle? No, so we can't use basic SOHCAHTOA. Does it have a known angle and a known opposite side? A known angle and a known opposite side. It is not a candidate for the law of sines then. We are forced to use the law of cosines. Something squared equals something squared plus something squared minus 2 times something cosine something. I know. Pretty cool. The interesting thing is that one of these two, I'm guaranteeing you right now, okay, or money back guarantee right now, that one of these is the variable. One of these is the variable. If that's not the case, you're in trouble. Okay? We would like to find side C. Now remember, this says solve the triangle. What I want you to notice is whatever angle you have, you want to find the side opposite that one. So where do you think the 20 should go in my formula? It's the cosine, right? It's the angle. And what is the side opposite it? C. Do you know, folks, that's the most important decision you just made in that formula. Just like when you are finding the hypotenuse of a right triangle. knowing which one is the hypotenuse and where to put that in the Pythagorean theorem is the most crucial thing you can do. After that, I don't care which one of the legs you call which, A or B. This decision we made is the most important. Now, I need an A and a B and an A and a B. I just need one of each in those spots. It doesn't matter whether you put the 5 first, the 11 second, the 11 first, and the 5 second. Quick question. Can you add up all of this stuff on a calculator?
Yes, you could add them all up.
Yes.
Order.
Okay, so c squared equals
Get one.
5 squared plus 11 squared minus 2 times 5 times 11 cosine 20 for a grand total of what? 42 point what? 63, something like that. And then what do you do for your slam bam finish? Square root. This is the easy version of the law of cosines, folks. Right? Well, I wouldn't say hard, but it is definitely more difficult than this. So like 6.53. That was pretty easy, right? Okay, now that you have 6.53, okay, so I was working on this example and I found a flaw from when I was teaching in class. I found a flaw in the law of sines. So as we were doing this example in class, we found that C was 6.53, and my immediate reaction was, hey, we've got a known angle and a known opposite side. Let's just use the law of sines. Well, if you'll notice down here, I did the law of sines in the bottom left, and I got about 36 degrees when I did that. But then I went over here and I did the law of cosines. Again, remember, I was hoping to try to avoid the law of cosines, but I see a problem. So when I did the law of cosines, you'll notice that I came up with a completely different angle. In fact, I came up with the supplement, or pretty close to the supplement. And so I have exposed a flaw in the law of sines, and it has everything to do with the inverse, or the range of the inverse sine function. So we cannot trust the inverse sine function. I know that there is a situation if you're dealing with the largest angle. So if this angle right here were the largest angle in the triangle, then it would be okay. But because we're not, we're actually we're putting ourselves into the ambiguous case of the law of sine function. So if you want to avoid having that problem with the ambiguous case, then I do not suggest you go to the law of sines on trying to find the second angle. I suggest you go through the process of finding that second angle with the law of cosines. Then you can switch to good old geometry, right? 180 minus 20 minus 144.8 to find your last angle, which, what is that? 180 minus 20 minus 144.8 gives me 15.2 degrees. So angle C or angle B was 15.2 degrees, which takes care of that problem that some of you were having when you were checking your work and you were coming up with different answers than the book was giving you. So sorry for the confusion on that. I'll try to make corrections on the next example too. Yeah, we could have found A with the law of sines and then subtracted to find angle B. All right, so all that stuff for finding angle A. All right, we've done enough of that stuff. I know you are capable. So let's move on to example 2. So we got a 9, we got a 7, and we got a 5. It says solve the triangle. Okay, pick an angle, any angle. We'll go with Mr. Urich. What do you got? Which one do you want? You want A, B, or C? You tell me. He's looking for angle A. Do we have a right triangle? Without actually going through the Pythagorean theorem to check it out, 5 squared plus 7 squared equals 9 squared, and I'm pretty sure it probably won't. But does it have a known angle and a known opposite side? Nope. So we are definitely not using the law of sines. So we're probably forced to use the law of cosines. No.
No. But it's still good to remember.
Exactly. Because you want the test to go quicker, So, but yeah, we'll have it on the formula sheet for you. So your most important decision is at the opposite ends of the formula. What should we put on the far right? According to Mr. Urich. Angle A. He wanted to find angle A. So I'm going to put angle A. Now, if you would like to call angle AX like it's some sort of secret witness protection program, then yes, we could do that. That's not a problem. So if you're all about renaming it because you like to give it different names, you could call it SpongeBob. I don't really care. Okay? Okay, now, what is on the other side of the equal sign? 9 squared, right. That's the most important decision you have to make. Right? And then we got a 7 and a 5 and a 7 and a 5 in what order you really want them, as long as you got one of each. This is where I'm worried, folks. Okay? I'm worried that the wheels are going to fall off. Okay? So, this is what I'm gonna put a box around this. Please don't do this. This is what one of my great fears. Because the last example, we could type everything straight across into the calculator and hit the equal button and then take a square root. This is what I see year after year after year. You guys think that you should be able to combine all of that stuff right there. That is completely illegal. Okay? Remember this example, this Algebra 1 example way back here? You swore to me. You swore on your life that you would not combine these things together and come up with 7x. You swore it. You were all like, no, nobody would ever do that. Well, how come they all do it when we get down here? I shouldn't say all. That's an overgeneralization. You're right. Okay? What should we do? We should probably figure this stuff out right here, right? Okay, what is 7 squared plus 5 squared? Yeah, well, what do you get? 49 plus 25. 74? Is that right? 49? Okay, yep. And what is this thing right here? Negative 70 cosine A. Don't you dare subtract 74 and 70. Don't you dare. Don't be that kid, folks. Because that kid right there is going to divide both sides by 4. And what is 81 divided by 4? 20 and a quarter.
How do you know that?
81 divided by 4? Okay, 4 goes into 80 20 times, and then there's 1 left over. Okay, now, what is the largest cosine in the universe? 1. How could I get a cosine of 20 and a quarter? I couldn't. That's where kids start getting domain errors on their calculator. So before you make that kind of mistake, what should you be doing with this number? Subtracting it. After that, what should you be doing with this number? Dividing it. And then the last step would be to get rid of cosine by doing what? Cosine inverse. I need to get my document camera working here because I'd like to show you how I like to do it. But you can do it, obviously, one step at a time if that's your preferred method. So let me get this plugged in. Super soon. Is it?
got what Grace said.
All right, let's get this document camera working. All right, 9 squared. I don't even care that it's 81. Why isn't it showing up? Oh, it's in the blind spot. I was like, wow, why isn't it showing up? Okay, now, watch what I do. Minus, parenthesis, 7 squared plus 5 squared. Now, I don't even care that it's 74 and there's an 81. I do care about subtracting it to the other side. Then I'm going to divide. You told me to divide, but watch what I divide by. Negative 2 times 5 times 7. I don't even care that that's negative 70. And then I invert the cosine of the answer. Oh, can't type. Invert the cosine of the answer. So there's 3 steps. Subtract, divide, invert the cosine. Now, if you want to, figure out that it's 81 and 74 and negative 70 and show that, that's fine. I don't care. Okay. But we should have gotten 95.7 degrees for that angle. Now that I have 90, any questions about what I did? Subtract, divide, invert cosine. Okay. So, is that it? No, that ain't it. It's over here. So we came up with angle A at 95.7. And if we know that, then what can we do to find the other 2 angles? Okay, now, our first this is going to be another example where we look at what happens after you've done the law of cosines. And you found your 95.7 degree angle, right? We put that in our triangle. When we go, if we go to use the law of sines, and we see we got our known angle and our known opposite side, and we do sine 95.7 over 9 equals sine b over 7. We cross multiply, we invert the sign, we end up with 50.7 degrees. Well, let's compare that to what happens if we use the law of cosines again. Okay, we come over here to the right side and we got 7 squared equals 5 squared plus 9 squared minus 2 times 5 times 9 cosine b. We subtract that very first chunk, right, the 5 squared plus the 9 squared. We divide the next chunk, negative 2 times 5 times 9. We invert the cosine because it ends up being 0.63, and we invert the cosine. Look what we get. We get 50.7 degrees. Now, why did it work this time, but it did not work the last time? Here is the mathematical answer. Because you were your law of sines works fine as long as you're dealing with the largest angle. And A is the largest angle. And how do I know it's the largest angle? Because it's opposite the largest side in the triangle. We could not guarantee that in the last example because we didn't have all the information in the triangle. So, or maybe did we? I don't know. Maybe we did. Yeah, we had all the sides. We could have made that correct decision. So what I'm getting at is this. You are going to be safe if you find that next angle with the law of cosines. You have to be careful if you're switching to the law of sines. So my suggestion is to use the law of cosines twice, right? Once to find angle A, once to find angle B. Then I can switch to my basic geometry stuff, right, where I'm subtracting those to find out angle C is 33.6. So That's what I would do. That's my suggestion to you, which this is, I'm glad I learned something today. Since I've never run into this, I've only looked for one angle. I've never looked for all of the angles of a triangle. So, don't know why I didn't come across that before. So that's my explanation as to why we were getting some weird stuff. I'm sure you'll be fine. It won't be that big of a deal. There is the area of a triangle. Now, the area of a triangle would be, you guys are all used to seeing 1/2 base times height from geometry class, but did you know you do not need to know the height of a triangle? Well, if you use trig in order to figure out the height of a triangle, you're basically doing that if you go through the process of proving this, you'll see what I'm talking about. We got A there, we got B here, we got side C here. I guess have you guys ever taken a half day off school called a half absence? I know, folks, they count it as a full day here, blah, 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 blah. Okay? But if you've ever taken a half day off school, it's called the half absence. And if you know anything about area, the formula would be 1/2 AB sine C. And if you look at that, folks, that says half absence.
Why don't they do half absences here?
Okay, focus.
It's the way.
Okay, half absence. That is your formula for finding the area of any triangle. Now, look at where side A, side B, and angle C are. Look at where they are in relationship to one another. Is the angle, how would you describe the angle? In between the two sides, thank you very much. As long as you have two sides and the angle in between, you can find the area of any triangle. You literally, so surveyors can go out, and if they're trying to measure the area of a triangular piece of ground, they can literally measure this distance, and the angle in between and tell you the area. Okay, we'll pick it up later when you get back. So this particular half absence formula, it's not that difficult to use, folks. If you have two sides and an angle in between, you throw them in the formula and you're done. I mean, you actually have to type it on a calculator, but you know what I mean. Okay, so situations like this aren't too bad. What's the angle in between? Octagons have how many of those triangles in between? 8, right? So each one of those, so theta there is what? 360 divided by 8. Wow, this should be a good one. A nice one. 45 degrees, that's right. So as long as you have the two sides and the angle in between, you could throw them in the formula. Now, how many of those triangles do you have in an octagon? 8. So once you got done, you'd multiply that entire thing by 8 for this particular question. But it's not really that hard to use the formula as long as you know the two sides and the angle in between. So that won't really be that hard for you to do. There is another formula on your formula sheet. You don't even have to know the height of a triangle. As long as you know all three sides of a triangle, there's another theorem called Heron's formula, which you've never seen before in your life. And you'll notice that they designate this formula. S stands for the side lengths. I should say S stands for the semi-perimeter. Okay? Now, how do you find a semi-perimeter? Well, it tells you right there in the formula. A plus B plus C, oops, ran out of space, all over 2. That's what they call the semi-perimeter. And they're labeling it S. So if you can add 3 numbers together and divide by 2, you can find what they call the semi-perimeter and use that in the formula. But yes, you would be given that formula on the test. We'll even throw in the semi-perimeter just for free. Okay?
Throwing everything.
Yes, yes.
It's like in law of Cosines.
So if you know the three sides of a triangle, so in this particular case, what would S be? 13 plus 15 plus 18 all over 2. What's the semi-perimeter? What do you got there? 28 plus 18, 38 plus 8, 46? What's 46 over 2? So the semi-perimeter is 23, so if I'm following that formula, so I got 23 times 23 minus 13 times 23 minus 15 times 23 minus 18. Boy, all you have to do is throw it in the formula. So I'm pretty sure you are more than perfectly capable of 23 times 10 times 8 times 5. Take the square root and come up with the approximate value of that. What is 230 times 40? 230 times 40, 9,200. Take the square root. I got 95.9. So we will be answering questions over the law of cosines tomorrow and reviewing for your test, then reviewing for your test on Wednesday. So just keep that in mind. We'll make Thursday the test for this.